Assalamualaikum dan selamat sejahtera. Nama saya Muhd Fikri Hakim matrik nombor S56828 akan membentangkan tajuk Electrical Machine FEI 4307 dengan tajuk Basic Induction of Motor Concept. So first, what is an induction motor? An induction motor, also known as a synchronous motor, is commonly used as electric motor in the induction motor. The electrical current in the rotor needed to produce torque is obtained via electromagnetic induction from the rotating magnetic field of the stator winding. The rotor of an induction motor can be squirrel cage rotor or the one-type rotor. These are the figure of the two rotor, squirrel cage and also the one-type rotor. So the induction motor are referred as the synchronous motor because they operate at a speed less than their synchronous speed. So for my information, what is a synchronous speed? A synchronous speed is the speed of rotation of the magnetic field in the rotary machine, and it depends upon the frequency and number of poles of the machine. The induction motor always runs at a speed less than its synchronous speed. The rotating magnetic field produced in the stator will create flux in the rotor, hence causing the rotor to rotate. Due to the lag between the flux current in the rotor and the flux current in the stator, the rotor will never reach its rotating magnetic field. These are the formula for the rotating magnetic field, where F is stand for the frequency and P for the number of poles. Construction. A typical motor consists of two parts, namely stator and rotor, like other type of motor. And outside stationary stator having coils supplied with AC current to produce a rotating magnetic field. And inside rotor attached to the output shaft at the given torque by the rotating field. These are the figure for the induction motor construction. So stator construction. The stator of the induction motor is laminated iron core with slots similar to a stator of a synchronous machine. Holes are placed in the slot to form a three single phase winding. This is the figure of the single phase stator of winding. There are two types of induction motor, single phase induction motor and also three phase induction motor. These are the induction motor. So my second question is, there are two types of rotor. There are two types of rotor in the induction motor. So what is it? They are squirrel cage rotor and one type rotor. So for the squirrel cage rotor, in the squirrel cage rotor, the rotor winding consists of single copper or aluminum bars placed in the slot and short circuit by end rings of both sides of the rotor. Most of the single phase induction motor have squirrel cage rotor. One or two fans are attached to the shaft in the side of the rotor to pull the circuit. So one type rotor. In the one rotor, an isolated three-phase winding similar to the stator winding, one for the same number of poles as a stator, is placed in the rotor slots. The end of the connected rotor winding are brought to the three slip rings on the shaft so that the connection can be made to it for the static or speed control. Usually for large three-phase induction motor, rotor has the winding the same as the stator at the end of each phase is connected to the slip ring. Compared to the squirrel cage rotor, one-type rotor are expensive and require maintenance for the slip rings and brushes. So it's not commonly in industry application. These are the one-type rotor for induction motor. So the basic working principle of the induction motor. Induction motor supply needed to be given for the stator winding as well as the rotor winding. But in the induction motor, only the stator winding is fed with an AC supply. Alternative flux is produced around the stator winding due to the AC supply. This alternative flux revolves with a synchronous speed. The revolving flux is called a rotating magnetic field (RMF). The relative speed between stator RMF and rotor conductor causes the induced EMF in the rotor conductors. According to the parallel law of electromagnetic induction, the rotor conductor are short circuit and hence the rotor current is produced due to induced EMF. That is why such motor are called an induction motor. It's same the occurs in transformer, hence the induction motor can be called as a rotating transformer. Now the induced current is in rotor will also produce alternating flux around it. This rotor flux lag behind the stator flux. The direction of the induced rotor current according to Lenz's law is such that it will tend to oppose the cause of its production. As the cause of the production of the rotor current is relative velocity between rotating stator flux and the rotor. The rotor will try to catch up with the stator RMF. Thus, the rotor rotates in the same direction as the stator flux to minimize the relative velocity. However, the rotor never succeeds in catching up the synchronous speed. This is basic working principle of induction motor of an ideal type single phase of the three-phase induction motor. However, for this current to be induced, the speed of the physical rotor and the speed of the rotating magnetic field in the stator must be different, or else the magnetic field will not be moving relative to the rotor conductors, and no current will be induced. If by some chance this happens, the rotor typically slows slightly until a current is reinduced, and then the rotor continues as before. This difference between the speed of the rotor and speed of the rotating magnetic field in the stator is called slip. It is unless it is the ratio between the relative speed of the magnetic field as seen by the rotor, the slip. So the speed of the rotating field due to this induction motor is sometimes referred to as an asynchronous machine. So the third question is, what is slip? Slip is the differentiation between synchronous and asynchronous speed. The difference between the synchronous speed and electric motor magnetic field and the shaft rotating speed is slip, measured in RPM or frequency. Slip will increase with increasing load, providing a greater torque. So the concept of the rotor slip, the speed of the rotor relative to the magnetic field determines the voltage induced in the rotor. The relative speed is used because the behavior of the motor depends on the voltage and the current in the rotor. The two terms used to define the relative motion between the rotor and the magnetic field are the slip speed and the slip. The slip speed is different between the synchronous speed or the rotor speed. When the rotor turns at the synchronous speed, s equal to 0, and when the rotor is stationary, s equal to 1, all motor speed fall between these two limits. The mechanical speed of the rotor shaft can be expressed in terms of the synchronous speed and the slip. So lastly, the electrical frequency of the rotor. Induction motor have been called rotating transformer because they work by inducing voltage and current in the rotor. The primary or stator induces a voltage in the secondary rotor, but the secondary frequency is not necessarily the same as the primary frequency. If the rotor is loud, it will have the same frequency as the stator. If the rotor turns at synchronous speed, the frequency of the rotor will be equal to 0 for any speed in the between. Yeah, that's all for me. Thank you for listening.